Okay, so next question is, this may be, I think, example 6. So if we have two vectors, a1 minus 1 and 2, and a2 3 and 0, and 0, and a vector b as 2 and 0, 2 and 1. So then can we represent a1 and ab as a linear combination of b, which means that if we have some scalar x1, okay, and then we take a vector a1, and then we have another scalar x2, we multiply it with vector a2, and then that will be equal to vector b. So then that will be the linear combination of a and a1 and a2, and then that will be equal to b. So we need to find such combination. So this is actually nothing but the a form of vector form of the system of the linear equation. So in this case, then we can write the system of linear equation as minus x1 plus 3x2 is equal to 2, and then 2x1 plus 0x2. Okay, so that means 0x2 is equal to 1. So we have this system of these two equations, and fortunately the second equation is very easy to solve. So in this case, second equation will give the value of x1 is equal to 1 by 2, and then input the value of this x1 is equal to 1 by 2 into this first equation. So we can get minus 1 by 2 plus 3x2 is equal to 2. So 1 by 2 goes there, so it will be 5 by 2. So x2 will be equal to 5 by 6. Okay, x2 will be equal to 5 by 6. So it means that the answer is yes, we can represent these two vectors a1 and a2 in terms of this. So this we can also verify it. So for example, if we put 1 by 2 minus 1 2 and then plus 5 by 6 3 0, so if we solve it, so it will be minus 1 by 2, okay, minus 1 by 2, and then that will be 1, and then this will be 3, then it will be 5 by 2, and then this will be 0. So what it will be, 5 by 2 minus 1 by 2 is actually 2, and 1 plus 0 is 1. So it is actually equal to b. So it means that we can represent this into linear combinations. That means a1 and a2 can be represented as a linear combination to result into b. We can solve another example. In this case, let's do it on this new page. Example 7. So if we have vector a1 as 1 0 1 and vector a2 as 2 1 0 2 1 0 and vector a3 as 1 minus 3 1 1 minus 3 1, and then vector b as 971. So then the same question, can we represent a1, a2 and a3 as a linear combination of b? So which is the same as the solving this system of linear equation represented by these vectors. So I think you understand that if I write it as an augmented matrix, to apply the method of elimination, Gauss elimination, or any method if it is easier. Okay, so the augmented matrix will be 9, 7 and 1. Okay, so in this case you need to apply this Gauss elimination. I decide to apply the Gauss elimination method. So this is already 0. If I want to make this 1 as 0, so what I will do is I will take minus R1 and then I will add it to R3, row 3, then that will give you a new row 3. So in this case it will be 1, 2, 1 and then 9 and then 0, 1, minus 3, 7, and then it will be 0 and then 0 minus 2 is minus 2 and then 1 minus 1 is 0 and then 1 minus 9 is minus 8. So in the next step, now this is the pivot point or the leading term. So I need to make this 2 as 0. So what row operation I will do, use that will be minus 2 times R2. So I will multiply this row by 2 and then I will add it to the row 3. So that will give me a new row 3. Okay, so in this case I will get 1, 2, 1, 9 and then 0, 1, minus 3, 7, and then it will be 0 as usual, and then it will be 0, and then since I multiplied it by minus 2, it will be plus 6 plus 6 plus 0, so it will be 6, and then it will be minus 14 minus 8, that is minus 22. Yes, actually there is some mistake here. The second row should be multiplied by plus 2. Okay, and then it will be good. So plus 2, so if it will be multiplied by plus 2, then it will be 2, and then 2 minus 2, that will be 0, and then it will be minus 6, so it will be minus 6 over here, and then it will be 14, and then 14 minus 8 is 6. Okay, it will be 6. So now it is easy to apply the back substitution. Okay, so this from the last equation, so this is minus 6x3 is equal to 6. So x3 will be equal to minus 1. And from the second equation, it is x2 minus 3x3. So 3x3, x3 was minus 1 and equal to 7. So from here, x2 will be equal to 7 plus 3, that is 10. And yeah, is it correct? So 1 and then x2 minus 3 into minus 1 is plus. So 7, and so it is 7 minus 3 is 4, because this is minus 3 into minus 1, it will be plus 3, and then this plus 3 goes over there, so 7 minus 3 is 4. So x2 will be equal to 4. And from the first equation, so x1 plus 2 x2 was 4, and then plus x3 was minus 1 equal to 9. So from here x1 will be equal to now 9 plus 1, 10, 10 minus 8 is 2, x1 will be 2. So therefore we can write this a1 and a2 something like this. So it will be, we can write like 2a1 plus 4a2 and plus that is minus 1 minus 1 a3, so minus a3, that is b equal to b. So where a1, a2, a3 and b are these given vectors. So it means that we can write a1, a2 and a3 as a linear combination to obtain this vector b. Okay, as a last example, I have these three vectors, and then I need to determine whether there is any linear combination for them to return into this p. So I have quickly written this augmented matrix, and then I can apply some of the row operations. So in this case, the row operation, maybe I need to make it 0 like this over here. So I can take minus r1 and then add it to r3, then this will be the new r3. So this will be 1, 2, minus 1, 0, and 0, 1, 1, 1, and then 1 minus 1 is 0, 0 minus 2 is minus 2, minus 3 plus 1 is minus 2, and then 3 minus 0 is 3. And now I can make this as 0. Or what I can do is over here I can take I can divide the last row by minus 2, okay, or I can make it 0 as well. Anyway, so as a next row operation, I can take like 2 times of row 2 and then add it to row 3, and that will be the new row 3. So it will be quickly 1, 2, minus 1, 0, 0, 1, 1, 1, and then it will be 0, 0, 0, and then it will be 5. So now here is this problem. So now I have this consistency problem, because the last equation now shows me that 0x1 plus 0x2 plus 0x3 is equal to 5. So this means from the last equation I get 0 is equal to 5, which is impossible. Okay, so when we get this impossible situation, then that means that the system of equations is inconsistent system of equation. Therefore it is not possible to have a linear combination of a1, a2 and a3 is not possible. Not possible for what? Not possible to obtain the given value of b. Okay, that means in this case we cannot have any linear combination of a1, a2 and a3 to get the linear combination of b. So more precisely, it is not possible to express b as a linear combination of a1, a2 and a3. So this is our conclusion.